Alrighty, guys, so this is the unit, actually not the unit, the whole entire cumulative final exam review for this. So I'm gonna go through each unit and make sure that you guys have your notes out and that you're taking notes. Also, know that you can use your notes on the tests. You just can't have any other open tabs, so you can't be Googling, and also please don't use your phones. Okay, so the first unit is probability. And two-way tables, right? So this is gonna be your little mini cheat sheet, right? So if I have probability of A given B, right? If you're given B, that means that is the only thing that you're looking at, right? So to find this, you find the probability of A and B, right? This is and you put it all over the probability of B, right? So if I'm looking at a given set, so like if we're looking at the lottery, right? And it's like, what's the probability that John wins given that it is male, right? If you're given that it's male, then none of the females have won, or whatever gender they choose to be, right? But if it's male, then that's the only set that you're looking at, right? Nothing else is going to be a possibility. There's no chance that I'm going to win because I am not male, right? So then looking at that, that is what you're looking. You're looking at what you're given and then find the probability of what you want out of that. All of probability is what you want out of what you have, right? And that's going to be between 0 and 1. So 0 is like no chance, never going to happen. And then 1 is like 100% chance, this is for sure it's going to happen, right? Other things you need to know, this is and, right, is this symbol. And this you multiply the fractions, right? If it's or, then it's this symbol and you add the fractions, but we didn't really see any of those. Okay, that is unit 1 in a nutshell. Okay. Unit 2, so looking at this is nonlinear functions part 1. Nonlinear functions part 1. Okay, so a couple things you need to know. These symbols, this is a ceiling function. This is a floor function, right? And for all of these, what you do is you round to the nearest integer, okay? Ceiling functions, you round up. Floor functions, you round down. So if I have the number like 5.5, right? Then when you have these ceiling functions, all of your rounding stuff that you've learned in like grade school, that stuff is overruled by this function, right? So it's 5.5, no matter what, 5.1, 5.9, any of those in here, this would round up to the next integer, so 6. This one would round down to 5, right? So even if it's 5.9, if you see this floor function, it rounds down to 5, okay? Other thing you need to know, when you see the words domain or when it asks for the domain, right, you're looking at the x values and you're looking at the left and right. So how far does it go to the left? How far does it go to the right, right? If you want range, you're looking at the y values, right? This is the up and down, right? So how far does it go up? How far does it go down? A lot of times you'll see like the graph like this, right? So that means that this is how far it goes down, and you're looking at like -3 or greater is what you're looking at for that. Okay. Other things you need to know. Oh, last piece you need to know for this one, and this is based off of each unit test that we went over. Absolute value function. Okay, so this is y equals a absolute value of x minus h plus k. Your vertex is going to be, sorry, not that one. It's going to be hk, right? So please note that this right here, this h and this h, They're the same thing, but notice that there is that minus sign right there. So that minus sign needs to be there. If it's a plus sign, then you need to like figure out how to rewrite it so that you can have that minus sign there. Okay. Other things to note with that. If your A is greater than 1, then your graph will be more narrow because it's growing faster. If your A is between 0 and 1, then it's going to be wider, right? So if you're thinking about like 1/2, and when I say A, I'm talking about this one right here, right? If you are confused with any of these pieces, go through my review videos for the units. I did not have enough time to make one for every single unit. I apologize, but for this one, there is. Okay. So that is the graph. All right, nonlinear functions part 2. Part 2. So one, you want to know the parent functions, right? So looking at the parent functions, let's draw these out. Okay. So if I have this function, please write this with me. This is y equals x. What you're looking at the function is you're going to look, this is linear, right? There's your function. That's your parent function. That's how it's growing, right? And then anything aside of that, y equals 2x, y equals x plus 5, that changes what your graph looks like, okay? So the next one, if I have this function and I have something that looks like this, this is y equals the absolute value of x, right? So absolute value is distance, which means distance is always positive because you cannot build a negative building, you cannot measure negative inches and stuff like that, which is why it bounces back up on this side. Okay. Okay, other parent functions. Here we have, I don't think you need to know this one. Let's go to the next one. Let's go to this one. So this is y equals x squared, right? And then I'm just going to go through the ones that I've seen on your tests. The last one is going to be, these are just sketches, right? This is y equals the square root of x, right? And then one thing you need to know about this one, especially from what I've seen, is if you want to reflect it over the x-axis, then it's going to equal, or it's going to be y equals negative the square root of x. If you want to reflect it over the y-axis, right, then it's going to be y equals the square root of negative x on the inside. Okay, if you're confused at this point of any of them, go back into your lessons, go through the instructions part of it. Their lessons are not the most exciting things, but it's very useful and it's pretty clear. And then if you have questions where you're like, I have no clue what this is, that is when you need to email me and set up a time to meet with me. Okay. The other thing you have is going to be y, y equals a to the power of x, right? So this is exponential growth, right? And this is important to know because this is how money grows, right? So there's two ways that money grows. One is linear, which means it's growing like that. And then one is exponential, which means it grows slowly at first and then it shoots up, right? And this is kind of how businesses work too, right? So this one right here, that A is going to be the multiplying factor. Okay. And I'd love to go over examples, but that's going to take really long to go through every single one of these units. So please go back and review the unit review videos for those. Okay. I need to clear this. So if you need to, pause it, copy down the notes, and then we'll move on. Okay, next one. We're looking at circles part 1. right? And then there were 3 parts. So circle part 1, you need to know, first of all, that central angle, right, is equal to the arc, the measure of the arc angle, right? Okay. Then we have these examples. So this one is if it's within the inside and you have 2 chords going on the inside, you know that these angles right here, they're vertical angles. Vertical angles are congruent, which means they equal the same thing, right? Then you have this arc, which is 1, arc 2, okay? So to find the measure of angle X, right, what you do is you take 1/2 and then you take arc 1 plus arc 2, right? Those measurements that you get, okay? The second option that you have is here, right, where it's within. This is X, this is arc 1. So to find the measure of angle X, this is the angle symbol, right? You have 1/2 times the measure of arc 1, right? And then notice that this one right here, the vertex, is on the edge of the circle. Central angles, it looks like this, right? So if I have the center right here, this is my angle and it's touching the center, right? So that means that X and arc 1, those are the same thing, okay? When you draw it out all the way to the edge of the circle, that's when you cut it in half. Okay, third one, and last one for this one, is if you see something like this, right? So if you have 2 arcs that it's intercepting, right? Because it's not always going to look like this, but you have 2 of these right here. This is 1 and 2, and this is X. To find the measure of angle X, you're going to take 1/2, and then you're going to take arc 2 minus arc 1. Okay. Other things you might need to know for this one is if you have a, oh, that might be the second part. Okay, so let's go to this part 2. Circles, part 2, okay? These are the segments. So segments, if I have these segments here, I'll color code it for you. This is A, this is B, this is C, and this is D, right? When you do this, to find the segments, if you have missing ones, if you take A times B, so on that same segment, this is going to be equal C times D. All right, so that's the first one. Second one is looking like this, right? So there's going to be more letters here. So if I have segment A, B is that point here, C, D, E, right? The formula for this one is if I take segment AC, which is the entire thing, right? The entire secant that cuts through all of it, and then I multiply it by the outside. So BC, this is the outside, right? So that part is just this right there. Right? It's going to equal the same thing on the other side, right? So the entire segment, which is EC times DC, which is the outside, right? So outside, whole thing. Right? And this is what I do for all of my tests. In high school, they used to let us get flashcards, and then you can write everything on a flashcard. I would literally write all of this my entire semester on one flashcard. So you just have to have small handwriting. Okay. And then the other notes right here, if you have a triangle through the diameter, then it's a right triangle, right? Also, if you have a radius and tangent, it's a right triangle. I think those are the ones that I saw, right? So I'm going to show you what this looks like. So here's the first one. If I have the diameter here and then there's a triangle inside, this is going to be the right angle, right? Not drawn to scale. And then if the other one that you have, if you have a radius and a tangent, so that means that tangent is going like this, then this is the right triangle. Okay, right triangle, super helpful. I don't think they explicitly taught this, but Pythagorean theorem. So I'm going to clear this. Take a second, copy it down. You can pause. Okay, so Pythagorean theorem, this is just a side note. This is for triangles. So if you ever cut a corner, this is what you're doing. This is for right triangles, right? And this is A, B, C. Then the formula is A squared plus B squared equals C squared. If we were in regular math class, I would tell you and teach you how that came about, but we don't have time for that. So that's just the side note that you need, okay? So circles part 2 is done. Oh, circles part 2 is still continued. Circles part 2 continued. Okay, so the other one that you have is something that looks like this, right? So if I have my letters again, this is C right here and D. Then you have the formula, right? So this part right here, so AB, if you square that, right, it's going to equal BC times BD. Sorry, the whole thing. Right. So this right here is the outside. This is the whole thing. Right. And that you just square it. They're going to give you measurements, right? So then you just kind of have to figure out the rest of it. Okay. Other pieces, right? If you have circumference, this is the outside. Right, so if you're walking around the circle, pretty much the formula for circumference is 2 pi r, right? Then when you only have a sector of it, right? So if I wanted to know just this piece, right? All I need to do is take the angle and put it over 360. That gives me a fraction. And then I do that. Okay. The area of a sector, right? So same thing. The formula for the area of a circle is pi r squared, but if I take my circle and there is my central angle, whatever that is, right? And the area, what I'm looking at is everything on the inside, right? So that's the pi r squared piece. You're still gonna do the same thing. So find your angle over 360 and then multiply it with the area. So it's just giving you a fraction, right? So half of it would be 180 over 360. And then you're looking at half of the area. So find the pi r squared and then take half of it. Okay. This is circles part 2. Almost done. Circles part 3. Again, you can pause it at any time to copy it down. Okay. Please take these notes because I passed this class already and I'm still writing it down for you. So it kills me when students don't write things down. Okay. Angles, right? So the measure of angle 1 and the measure of angle 2 is going to equal 180 degrees, right? Other things you need to know that I looked through the lesson for, the standard form for a circle is going to be x minus h squared plus y minus k squared equals r squared, right? HK is going to be the center of the circle. So this is when you have a circle on a graph, right? The other thing you need to know is the distance. And this is something that I think you guys learned in 8th grade. So distance is square root of x2 minus x1 squared plus y2 minus y1 squared, right? Oh, let me bring these all down. So x2 minus x1, y2 minus y1. Okay. And I think that's it for one more piece. Okay. Last piece for this is if I have parabolas, right? So if I have my graph right here and I have my parabola looking like this, right? Here is going to be the focus. Something down here is going to be the directrix. Okay, and the formula for this. So basically the focus and the directrix means that if I go to any point on this line, that distance and that distance, I know it's not drawn to scale, it's supposed to be the same, okay? So what you need to know for this is x squared. So let me draw out the points. The point xy is going to be 4p, this is the y coordinate of the focus, right? And then y. And then you use that, or if it's rotated, you're going to use y squared equals 4px, right? And so you're going to use this formula to figure out whatever they're asking for. Okay. Last one. Okay, 3D figures. Right, this one should have been pretty simple, right? So pyramid, right? There's two different types of pyramids. One, there's rectangular pyramids where your bottom is a rectangle and then it goes to a point. So, or there's triangular pyramids, which is a triangle and then it comes to a point, right? So this one is going to be 1/3 the area of the base times the height. Now this is the area of the base, okay? So your base is going to be either your rectangle or your triangle, right? And remember that the area of a triangle is 1/2 base times height for that triangle piece. Okay, so just make sure you know your areas. Okay, cylinder. Let's go to cone first. Cone. Cone is the same thing, right? So cone is pretty much a pyramid with a circular base, right? It's the same thing, 1/3 area of the base times the height, right? But your area of the base is different. So your area of the base is a circle, so it's pi r squared, right? That's your base. Okay. Volume of a cylinder. So here is a cylinder, right? And then this is volume is the area of the base times the height. This area of the base is a circle, so it's pi r squared for the area. Okay. Volume of sphere. Right, so you're looking at something like this, right? This is going to be 4/3 pi r cubed. So these are all just formulas that you need to know, okay? Cavalier's principle. So Cavalier's principle means that if you have two solids with equal height, right? And equal cross-sectional area, then it has the same volume. Okay, so what that looks like is if I have this rectangular prism and I have this cylinder, right? If the areas are the same and the heights are the same, that means the volume is the same. Okay. Okay, continuing on, pause if you need to. Okay, surface area of similar solids theorem. So surface area of similar solids, right? So the surface area changes by the square of the scale factor. So square of the scale factor, right? If it's the volume, of similar solids, then it's the cube of square factor, scale factor. Okay, so let me show you an example of this one, right? If I have this cylinder and I have this smaller cylinder and the scale factor is the same, so the height is 12, this height is 4, right? This radius is 3, this radius is 9, right? From here to here, your multiplier is 3, right? So 4 times 3 is 12, 3 times 3 is 9, right? So that's scale factor. You know that it's similar. If I wanted to find the surface area, right, then it's 9 times the amount, because when I square it, it's, oh, sorry, let me go back. The scale factor is, this is the scale factor, right? So squaring the scale factor, so times 9 would be the surface area. So if I found the surface area of this one, then it's times 9. If I want to find the volume, then it's the cube of it. So 3 times 3 times 3, which is 27 times the amount. Okay, that's it. If you have any specific questions, feel free to ask me, but this is like your cheat sheet for your notes for your final cumulative exam. If you have any questions, please let me know, and good luck.